Hello, hello, good evening, everyone, and welcome to our live stream here in our YouTube channel. This is your teacher, Teacher Maria, speaking to you right now. Sorry, I guess my microphone is a bit far from. There you go. I think that's better. I hope that you could actually hear me. Hello, good evening. Thank you for our viewers tonight. Good evening, everyone. And we are live. Once again, apologies for the for a few days. No, I think 2 weeks. I was not able to release videos in my YouTube channel. I have just been very busy with everything, with work and all those things. So I wasn't able to release educational video in our channel. But I hope that you bear with me. Bear with me as I try to catch up with everything, especially with making videos for our YouTube channel. But if you do have anything particular that you would like me to create as a video, please do leave a comment in any of my released video, and we will definitely make some videos for that. Thank you so much for our viewers tonight. Thank you so much. Welcome, welcome, welcome. Yes, thank you so much for our viewers tonight. And I guess as mentioned in our title, this will be more on factoring. We will be discussing the different ways to factor, and basically, you know already. So, what we are going to do tonight is more on um, practicing how to factor and how to identify the possible factors of a certain expression given to you in a problem. Sorry. Cool. Ouch. Yes. And yes, as mentioned previously, there is a higher chance that we will be cross streaming from with YouTube and Facebook. The reason being is we have students as well in Facebook, and most of the students actually check their Facebook uh, compared to YouTube. That which I have observed. So we'll try to see how it would be. Not so sure how to do it, but let's see. It's a bit of a complicated. It's a complicated process, but I'm not so sure how to deal with it as well. All right, cool. So we will be having topics for factoring, and I hope that you would be able to um, get the necessary ideas or learning from it. Okay, cool. So it will be math discussion tonight, and we will be focusing more on factoring. So when we say factoring, that means that from the word factor, we will be looking for that common multiplier or common value or variable within an expression. So when we say algebraic expression, we are talking about expressions that contains coefficients or numeric coefficients and literal or letters. So when we have, for example, we can factor out integers. So let's say you are given an example as 3y plus 6. So if you are given 3y plus 6, what you need to do is, what is a common number that is where, not that is, where your 3 and 6 are divisible with. So for this case, 3 and 6 both are divisible by 3. So that means that the common factor of 3 and 6 is 3. So when we factor out 3, we'll place 3 outside. So if we factor out 3 from the first given, if we take out 3, okay, what is left there will be y. All right. Plus, since that's the sign that you have here, 6, when you divide it by 3, will give you 2. So that means that you'll have 2 there. So 3 times y is 3y. 3 times 2 is 6. So that will give you back 3y plus 6. Hence, you have completely factored it correctly. All right, cool. So another example is, what if you have variables? For example, f cubed minus 2f. So if you have an f cubed minus 2f, by the way, for numbers or numerical coefficient, it's always the greatest common factor that you will look for. Greatest common factor if it's the numerical. So between 3 and 6, the greatest common factor is 3. So you always take the greatest. Now, if you have your variable, you always take the smallest exponent of that variable. So between f cubed and f, the smallest is f, right? Not f cubed, because that's greater. And if you don't see a number on your f, that's understood that its exponent is actually 1. So you factor out f. So since you have taken f, and if you have an f cubed, that's understood to be f times f times f. There's 3 of those f. So if you have taken f out as a factor, what is left? If you have taken 1 out, you're left with 2. So you have f squared minus 2. So that is your complete factor. Cool? Cool. Thank you for our 5 viewers tonight. Please do leave a comment and make use of our chat box. Say hi or anything. All right. So let's proceed with another example, and you try to answer them. It's very easy. Factoring is actually easy. First is identify what is common. Secondly is you have to determine what is oh my goodness, I'm lost with words. What is your common factor? See, I'm lost with words. All right, you had me at hello. X squared y plus xy cubed. Let's say, for example, let me use 4 here, so that you would see the difference between the two. So if you have this question, the first thing that you have to do, I feel like I'm too bright, but it's okay. The first thing that you have to do is identify what is, since they are both of them contains variables or letters or literal coefficient, what you need to do is take the smallest exponent that you have. So the first thing that you have to check, both of them has an x. So between x squared and x fourth, x squared is actually smaller, or the smallest. So hence you will place x squared outside. And then between your y and y cube, your y is the smallest. So you place y outside bracket. So since you have factored out x squared and y on the first term, we call this our first term here. So that's 1, so that when you multiply, you'll get x squared y, because you have factored the whole thing. You have taken out the whole thing. And you have taken x squared. So what is left for the second term will be x squared. You've taken a y. So what is left will be a y squared. So hence, this is your complete factor. Cool. So I have shown you, if it is a numerical coefficient, you get the greatest common factor. If it is a variable, you get the lowest exponent or the lowest degree of your literal coefficient. So let's say I'll give you a question where it's a mix. All right. I'll give you a question that is a mix. Let's say, for example, you have 12xy plus 3x cubed y squared. That's interesting. Thank you for our 5 viewers tonight. So what do you need to do? The first step is, with your number 12 and 3, what is the greatest common factor, the GCF, between 12 and 3? So between 12 and 3, 3 is the greatest common factor. All right. And then, and then you look into your x and x cubed. So you have an x. And then y and y squared, you have a y. So since you have, let me just place it down here, because x and then y. Okay. So since you have taken out 3, 12 divided by 3, you will have 4. Since you have taken x, you have taken y, so only 4 plus. So since you have taken 3 divided by 3 is 1, and taken 1 of the x, so you are left with square of your x, and 1 of the y, so you're left with y. So that when you are to check this, distribute, you'll get back the original given. Okay. I hope that is clear. Cool. All right. Let's try, let's do another example. I'll give you another example and you tell me what would be the answer. Okay. Let's say you have 20 A, fifth, F, B squared minus 16 A squared B. All right, cool. Thank you for our 4 viewers tonight. So looking at 20 and 16, all right, looking at 20 and 16, you have to look for a value between the greatest, not a value, a greatest common factor between 20 and 16. So the greatest common factor between 20 and 16 is 4. So you factor out 4. So between 20, 16, that is a 4. And then between A fifth and A squared, that is actually an A squared. So you have A squared. That's the lowest that you have. And then between B squared and B, that's actually a B. So then you have your open brackets. So 20 divided by 4 is a 5. Since you have taken out 2, what is left is 3. Since you have taken out 1, what is left is 1 of your b minus, that's the operation between the terms, and then 16 divided by 4 is 4. Since you have a squared out and b, and that's here as well, so it's only 4. So your final answer will be 4a squared b times 5a cubed b minus 4. Cool. Yes. Okay. I guess that will be clear enough. All right. Good evening, Mahablanca. Good evening. Oh, Colonel is not here. Yes, Colonel is not here. I'm not so sure. Probably Colonel is busy with. Hi. Hello. Colonel is not here. Mm. Yep. Okay. So the next topic, the next question. I miss Colonel. Yes, I miss Colonel too. Uh, Probably Colonel is busy with schoolwork. All right. So our next question is, what if you have an expression that contains brackets? So if you have this kind of question, you don't need to expand your brackets. Okay? The first thing that you have to check is whether the bracket that you have is the same for both. So if both has exactly the same term inside your bracket, then you treat your bracket as a term given. So you have here a squared, and this is just 1. So hence, your first is to factor out x minus 5 as one term, as a factor. And then you will have a bracket 4 times, there's 1 of your x minus 5 left there, plus 3. All right? Now, since you have too many brackets here, then this is the time that you distribute. So 4 times, so I'll just copy this. And then you will have 4x minus 20 plus 3. So you'll have your final answer as 4x minus 17. So that's your final answer. Yes. Is it clear? Okay. I'll give you another example and then you try to answer it. All right. So if it's a bracket, if a factoring required, thank you for our 7 viewers tonight. If the factoring required has a bracket, the whole bracket needs to be checked whether they are the same. So for this case, x minus 5 and x minus 5 is the same. They just differ on the power or exponent. So you take out the whole x minus 5 and treat it as one term. So x minus 5 is a common factor, and then you factor out one of which, because 1 is the lowest exponent, and then you continue factoring. All right, cool. Okay, let's try another example and you try to answer it as well. So let's say I have 3x minus y squared minus 2x minus y. Okay, so since you have again brackets, do not expand the brackets because you will just be complicating things. You just need to check, is your brackets the same? So if it is the same, then you treat it as a term. So you factor out, you have a square here and a 1 here. So that means that the lowest is 1, which is x minus y. And then what is left here will be 3 times 1 of your x minus y, because that's a squared. The operation that you have is minus 2, and then close. And then you factor out the 3x minus 3y minus 2. Then that's your final answer. Cool. It's actually raining hard here. You can't hear, right? There's thunderstorm. All right. Okay. Questions so far? You can always type in our chat box before we continue. Okay. So we started with what if it's a numerical coefficient that is common? And then we have what if it's the literal coefficient that is common? And then we have what if it's a bracket that is common? Now, what if we have a quadratic expression given? So what is a quadratic expression? A quadratic expression is when you have your x that is the highest possible exponential of your literal is a square. So let's say, for example, you have x squared plus x minus 30. This is a quadratic expression. All right. So that is a quadratic expression. Now, when you factor out quadratic expression where your x squared here has a coefficient of 1, okay? If your x squared has a coefficient of 1, all you need to do is find the factor of the last term that, okay, factor of the last term where the sum of it is the middle term. Okay. So you have negative 30. So I believe that will be a 6 and 5. So since this one is positive, so I'll have 6 times negative 5. That will give me negative 30. And 6 plus negative 5 will be 1, which is the middle term. So you will have x, what is it? X plus 6 and x minus 5. So this will be your factor. Cool. Cool is cool, but cool. Questions so far? Yes. All right. If there's no question, then we proceed with another example. Okay, so let's say you're given x squared minus 6x plus 8. So again, your first thing to do is check if your x squared here is with a 1 as a coefficient. Then if it is a 1, then you factor out the last term. You factor this out where the sum is the middle term. Now, since the middle term is a negative 6, that means that I will have negative 4 times negative 2. That will give me a positive 8. And negative 4 plus negative 2 will give me negative 6, which is the middle term. So hence the factor is x, and then you have minus 4, and then x, then you have minus 2. Hence, that will be your factor. That's it. Cool. Cool, cool, cool. All right. Tudurururun, tudurururun, tun, tudurundun, tudun, tun, tudurundun. Okay. Now, I will give you another example where, let's say, for example, too many examples. Let's say I'm given an expression x squared plus xy plus um, zx plus yz. Did you hear that? That is thunderstorm. If you hear it. Our dunia. Give me WhatsApp group Korean. I don't know. What do you mean by WhatsApp group? All right. So if you are given this kind of equation, then what you need to do is determine first what is common. No, sorry, Ardunia, but not so sure what you're talking about. I do not know any Korean WhatsApp group. All right, you learn Korean language. Oh, okay. Yeah, but not so sure. Not familiar with a Korean group. Okay, so what you need to do is check what is common. This and this is on factoring, Mathea. So you can group together x squared and xy, or you can group. You can also group together. You can also group together zx and yz, as long as you have something in common. So if you have something in common, then you can group them together. So what you can do here is you put them on brackets. So you have x squared. You have WhatsApp group links? No, so sorry. Dunia, I don't have. Plus xy and then plus zx plus yz. All right. And then you factor out what is common in this group. Common in this group is x. So you have x plus y. And then common in this group, you have z. So you have plus z and then x plus y. Now, if you would notice, you have here the same group, x plus y, x plus y. So then you can factor that out. So you will have x plus y, which is common between the two. And then what is left is x and z. So you factor x plus z. I need very much WhatsApp group learn Korean language. Oh, okay. So sorry, Dunia. But I think you have to ask for someone else. I don't know any Korean group. All right, cool. All right. So if you have that, you just need to group together what is common between the two. All right. Cool. Let's try. So the next question that I will give you as an example is, what if you have 2p squared minus p minus 10? What if you have a quadratic expression wherein the first term has a variable, or it has a number, or a coefficient, a number coefficient? So if you have checked my other a video, so sorry, Dunia, you might want to ask someone else. I don't know any Korean groups. So if you have welcome, thank you for dropping by. So if you have a 2p squared, what you can do is you can use the box method. So what is the box method? So it would look like this. All right. So then you find the factor of this, which is 2p and p. And then you find the factor of the last, a negative 10. So you can have 5 and 2. So I will place 5 here. Welcome. 5, and then I'll place 2, because 2 times 5 is 10. So since that's negative, and our middle term here, our middle term is negative p. So I will make my 5 as negative and my 2 positive. Why? 2p times 2 will give me 4p, and p times negative 5 will give me negative 5p. So when I add, that will actually give me negative p, which is the middle term. So hence, my factoring, or the factors that I'm using, is correct. So then you do the butterfly effect. Wow, butterfly. Now just cross over and cross over. Then you will have 2p minus 5 and p plus 2. Hence, this is your factors. Cool? Cool. Questions so far? Question. Da-da-dun. Da-da-dun. Da-da-da-da-dun. It's actually having, in my background, I could hear lightning and thunder. I'm not so sure whether you can hear it actually. Lightning and thunder. That doesn't sound like a lightning and thunder. Okay. All right, cool. Let's do another example, and we'll still use the same procedure. Okay. So let's say you have 6p squared minus 5pq minus 6q squared. Q squared. Right? So the same thing is loud. Yes, it's loud. Can you hear? Can you hear it? No. So you have 6p. You'll have, probably this is a 3p and a 2p. And then that's a 5. So I'm thinking whether you will get 3p, and since that's a 5, so that will be a 3q and a 2q as well. Okay, so since that's a negative 5, so I'll have this as negative and this is positive. So that 3p times negative 3q will get negative 9 qp, negative 9 qp, pq. Can you hear that? I can hear it. And then positive pq. So when you add this, you will have negative 5pq, which is the middle term. And then you do your butterfly crossover. And that will give you 3p plus 2q and then 2p minus 3q. And that will be your factor. Yeah, I heard the boogzh. You heard the boogzh. You heard the boogzh boogzh. Yeah, I can hear it clearly from my background. Boogzh boogzh boogzh. Cool. Sorry about that. Mathea, Mahablanca, is there anything that you would like to wait? Oh, if you would like to play, do we have enough players? All right. Mm-hmm. Specifically, mm-hmm. Okay. Um, what specifically about limits and theorems? Hmm. Can you hear that? Can you hear that? What game? Game. Exponential something. Okay. Let me just check if I have something about theorems and limits. All right. Okay. So, limits, specifically with limits. Mm, let me just. Ooh, that's very loud. Okay, limits. Okay. When you do limits, just think of the word when it says limit. That means that is where it's limited to. Okay? So when we say limit, that is where it ends or that is where it stops. So that is what we meant by limited limits. Okay? So where it's limited in terms of an expression. So if you have wait. Oh my. Can you hear that? Uh-oh. Wait. Let me just check. If I have an example that I can actually use. Wait. Exponential. Let me see if I can get examples. Let me just check with examples. Exponential. I'm not so sure. Okay, so when we talk about limits, just think of, let's say for example a balloon. If you have a balloon, it has a certain limit, and then it will pop, right? So the same thing with the limits in math. When we say limit, that means that you're looking at a very, very small region in your graph where it ends, like it doesn't go beyond that. So, so if you have a function, it's always defined with values. That is where when your x is getting closer and closer to a certain value. So it's always written as this: a limit of the function x is equal to a certain value when the x of your function approaches a. So that means that if your x as x approaches a, uh, without actually attaining the value of a, then you will get a number L. Then we say that L is the limit, that is where it ends as x approaches a. So no matter how x approaches a, your function will always be approaching your L value. That is what we meant by limit. So if we have a certain graph, let's say, for example, you have a graph, um, let's say you have a graph, and then you have this. All right. So let's say that's your graph. So this one, this is your f of x. And where it actually uh, like doesn't touch, but it's going towards it, this is actually your a. This is where it approaches. So as x approaches to. So if you have, let's say for example, um this one, let's say that one, it passes through 0, right? So then you can say that as x approaches, let me just make a bigger graph for you. Let's say you have this graph. Okay. All right. And then you have this. Okay. So let's say you have that point there. And this side of the graph is limit of your f of x as x approaches a from the right. Okay. So that means that it's actually from here towards that. That's from the right. And then if you have your limit f of x as x approaches a, and then you get a superscript negative, that means that it's from the left. So it's coming towards this direction. So as x approaches a. So let's say this is where your a is. So then you would say that limit of x cubed equals 0 as x approaches 0 from the right. And this one will be the limit of x cubed as it approaches 0, where x approaching 0 from the left. So that is what we meant by limit. So in theorem, when we say a function has a limit as x approaches a certain value, that is if and only if it has a left hand and a right hand. How should I say it? And one-sided limits are equal. So the limit exists for a certain function. So let's say you have, so let's say, let me just remove that. Let's say you have this, and then you have a line, then you say the limit exists, right? So the limit exists. Why? Because the left and the right are equal. But if you have a graph where you have this, okay, and then you have that, and then you have this, then you would say that the limit does not exist for this function. Why? Because your left here and your right is not equal. The other one is a solution, while the other one is not a solution. Cool? So if that is the case, then you could say that the limit of your function, um, I mean, it does not is not equal because it doesn't exist. All right. So how do you do it? Let's say, for example, another example. Let's say you have this one, and then you have this curve. We know that this is quadratic, and this is one. Let's say that's a two, and on two you have that. Okay, you have that. So you would say that limit of your x squared, and then this is 1, 2, 3, 4. Let's say that's a 4. Okay, your y is 4. So limit of x squared is 4 when x approaches 2 from the left. So where is from the left? So from the left is this one, that direction. That's from the left. And then you would say that the limit of x squared is also 4 as x approaches 2 from the right. So from the right, this is where the right side of the equation is, then it is also 2. Hence, we say that the limit of x squared is equal to 4 as x approaches 2. That means that this limit exists because our left and right is the same. Cool? Cool. Cool, 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 cool. All right. Now, I will show you one example where your limits does not exist or when your limit is the same. So let's say, for example, you have this, and then you have 1, 2, 3, 4, and then you have 1, 2. Okay. And then you have this as your graph. Let's say, by the way, if you see a solid dot, that means that it is a solution. And then if you see a halo dot, that means that it's not a solution. If you see a solid dot, that means it's a solution. If you see a halo or an empty dot, that means it's not a solution. Okay. And let's say that's 1 there. And then you have on 3. And then you have on 4. So let's say, for example, this is y equals f of x. That means this is the function. So then you would write that for this one, right? For this point here, you would say that as the limit of your f of x as x approaches 1, since both of this is not equal, the other one is a solution, the other one is not a solution. Hence, you would say it does not exist. It's a D and E. The same thing with this one, this halo side here. This is the limit of your f of x as x. The limit of your f of x, okay, is 1 when x approaches 2, because it is exactly the same. From left to right, it will give you exactly the same solution. All right. The same thing with this one. So if this is the limit, then you would say limit of f of x as x approaches what is this, 3, approaches 3, then the value is 2. Okay. And then of course this one will be the limit of f of x as x approaches 4 will be does not exist. Y is not existing because there's no right side. Because it ends there. You don't have a right side of your function. All right. So then you cannot say that it is existing because it doesn't have a right side. And the theorem states that a limit will exist if it has a left hand and a right hand limit. But if it is and both of these one-sided limits are equal, then you would say that it exists. However, if the left hand and the right hand is not equal, then you would say it does not exist. Or if only one side is if there's only one side of the limit, then it's not existing as well. Cool. I guess that will be everything tonight, unless there are questions so to ask. If not, then that's the end of our discussion. Cool, 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 cool. Cool, 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 cool. Yes. I guess we don't have time to play. And we're only less. What game, mom? I guess we will not be playing tonight if it's only us. We can play um one game. We can play actually one game. Cool. And I guess that's a thank you. It's a thank you. Let's just wait for a few minutes if you have any questions so far before we end our live stream. Yes. Any question, clarification, no game. It's only the three of us. Unless I'm not so sure if we can play a game when it's only three of us. Doo-doo-doo, doo-doo, 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 doo-doo-doo-doo. Let me know. Yeah. We only have anyway 5 minutes. No game. No game, no game. Questions so far before we end our live? Any question? Any question? All right. I guess that will be the cool. I think that will be the end of our live right now. And yeah, I think we cannot do a game tonight because it's only five of, unless all of you will be joining. So if not, then we will do the games next week when we have more. Oh, yeah. I can hear the sound of the thunder. So if there are no questions at all and all those things, then we will be ending our live stream right now, and I'll be seeing you next week. Next week for another topic that we will be discussing. Please do leave a comment so that we would be able to take up and do um discuss, not do, discuss the topic that you would like to discuss during our live. So I guess that will be all for tonight. And thank you. And I hope that you are able to, understand and learn something new today. And it's about factoring. So I'll see you next week. And this is your teacher, Teacher Maria, yours truly. And I'll see you next week, same time, same channel here in our YouTube channel. So I'm thinking of cross app live stream, but we will see how it would be. So thank you, good night, and God bless everyone. See you next week. Bye bye. Thank you, Maha Blanca. Thank you, Ardunia. Thank you so much. Good night and God bless.